reddish point of light pulses at the upper edge of the Orion constellation. What if Orion's red light is the ghost of a dead star? Telescopes registered an anomaly that exposed the true nature of this cosmic beacon. For millennia, humanity gazed at the night sky and mapped fixed figures, hunters, animals, and gods drawn with seemingly eternal points of light. The star Alpha Orionis, known as Betelgeuse, has always been the hunter's right shoulder, a safe navigational landmark, shining with an intensity that rivals the planets of our system. But modern astronomy revealed that this visual stability is an optical illusion. The fixed glow hides a nuclear engine that is in its final moments of operation. Betelgeuse is a red supergiant, a class of stars that live fast and die violently. Its mass consumes fuel at a rate that defies human comprehension. In October of 2019, this engine began to visibly fail. The hunter's shoulder began to disappear before the lenses of terrestrial observatories. The change wasn't subtle or restricted to complex laboratory charts. Any backyard observer could look at Orion's belt and notice the difference with the naked eye. The star lost its place as one of the 10 brightest in the night sky. It was a continuous decline that transformed the celestial landscape in a matter of weeks. The data indicated that something massive was happening on the star's incandescent surface, a change of behavior that forced astronomers to recalibrate their measuring instruments. The night sky was changing in real time, and science needed to document every photon. Those fascinated by this kind of cosmic mystery can subscribe. That's how the next episode arrives in your feed. This continuous decline in the celestial landscape compels us to look at the physical scale of the object. Betelgeuse is not just big, it's a thermodynamic monster in uncontrolled expansion. The distance to this supergiant is approximately 642 light-years. Despite this dark spatial abyss, its size is so colossal that it dominates our view of the constellation. If we could remove our sun from the center and place Betelgeuse there instead, the scenario would be absolute. The star's surface would instantly engulf the orbits of Mercury, Venus, Earth, and Mars. Its incandescent plasma would extend all the way to Jupiter's icy orbit. This absurd expansion is the direct symptom of a star dying from the inside out. For millions of years, it fused hydrogen into helium, maintaining a relatively compact and stable form. But the core's hydrogen ran out, and the perfect balance of stellar physics was broken. Without the pressure of the initial fusion, gravity crushed the star's core with brute force. The extreme heat forced the star's outer layers to swell uncontrollably into space. The density of the outer envelope dropped, and the surface cooled, acquiring a deep reddish hue. Today, Betelgeuse survives by fusing increasingly heavier elements in its hidden heart. Helium turns to carbon, carbon turns to neon, and neon slowly transforms into oxygen. Each new fusion cycle lasts a fraction of the time of the previous cycle. Hydrogen lasted millions of years, but carbon reserves are consumed in a matter of just a few millennia. The star is a cosmic pressure cooker with its timer nearing zero. And telescopes focused on its surface precisely to try to read the final seconds of this clock. Its internal rhythm dictated an unprecedented event in the final months of 2019. The instruments of the Very Large Telescope, isolated in the Atacama Desert, captured the thermal anomaly. The phenomenon was documented in scientific records as the Great Dimming. Between October 2019 and February 2020, the light failed. Betelgeuse lost about 60% of its total brightness in the visible spectrum. The silhouette captured by infrared sensors showed a massive, severely deformed sphere. The supergiant's south hemisphere seemed to have been swallowed by a dark, cold spot. In astrophysics, abrupt drops in luminosity in red supergiants trigger alert protocols. When the core finally begins to fuse silicon to create iron, the end of the line arrives in days. Iron fusion doesn't release energy outward, it absorbs the core's own energy. Without the radiation pressure pushing matter outward, the core enters total gravitational collapse. In the fraction of a second, millions of tons of plasma fall toward the geometric center. They hit the dense iron core and rebound in a devastating supersonic shockwave. The physical result is a supernova, a thermal explosion that tears the star inside out. Data captured in late 2019 suggested that this process might have begun. Space telescopes and terrestrial observatories interrupted their standard routines to focus on Orion's shoulder. The scientific community silently awaited the detection of the first high-energy wave of radiation. Telemetry charts on monitors were updated daily, counting every photon that reached Earth. The continuous drop in luminosity seemed like the thermal signature of a catastrophic collapse already underway. But the light curve on the observatory monitors slowly began to rise again. The star's brightness stopped falling in February, and the deep red returned to the night sky. If the dimming wasn't the explosion, does the current light belong to a living star? Data transmitted by the Hubble telescope resolved the mechanics of the Great Dimming. It wasn't the core collapsing, but the turbulent surface expelling its own matter. Betelgeuse suffered a coronal mass ejection of physical proportions unimaginable by our standards. The star vomited billions of tons of superheated plasma from its south hemisphere into the vacuum. This dense material traveled away from the surface and met the absolute cold of interstellar space. As it lost heat, the plasma condensed into a colossal cloud of entirely opaque stellar dust. This dark cloud of dust positioned itself precisely between the star and our planet's telescopes, a self-generated eclipse that temporarily blocked the visible light from the red supergiant. The star wasn't dying at that exact moment, it was merely shedding its outermost layers. A natural process of wear and tear, albeit extreme, in the final phase of a red supergiant. The star's surface was left with an enormous cold scar after the violent mass ejection. The surrounding plasma needed months of convection to fill the void left by the surface explosion. The visual illusion of an imminent supernova was dispelled by Hubble's spectrographic data. The star remained there in the dark, unstable, wounded on its surface, but structurally whole. The event proved that red supergiants are dynamic objects with chaotic behavior. The internal pressure of nuclear reactions continues fighting against gravity, postponing the inevitable collapse. The inevitability of the end, however, obeys a relentless mathematics imposed by the vacuum's distance. The light that Hubble captured passing through the dust cloud wasn't a live broadcast. The distance of 648 light-years imposes a fundamental delay on our observation. Every photon captured by the lenses of our instruments began its journey in the late Middle Ages. The great dimming we documented in 2019 physically happened in the 14th century. The light traveled through interstellar vacuum at 300,000 kilometers per second for uninterrupted centuries. This means the star's current mass state is a physically inaccessible mystery. Betelgeuse may have already exhausted its last drop of fuel and entered total collapse. If the silicon core fused into iron in the year 1600, for example, the supernova shockwave already destroyed the star's structure over 400 years ago. In this mathematical scenario, the ghost has already replaced the real star in the dark fabric of space. The explosion's light would at this moment be silently crossing our galaxy's spiral arm. When the supernova's light finally reaches Earth, the event won't begin with the visible spectrum. Hours before the photons arrive, our planet's underground detectors will register an invisible rain, trillions of ghost neutrinos, uncharged particles that escape the core before the shockwave. They will pass through Earth's rock almost without interaction, the first physical whisper that the star has died. Soon after this rain of particles, the visual brightness will drastically flood the night sky. A single concentrated point of light will become as bright as our full moon, a cosmic spectacle of radiation that will remain visible to the naked eye even during the clear day. The supernova's daytime brightness will be the final confirmation of our cosmic delay. The reddish light dominating Orion's shoulder today is already, in the practice of astrophysics, a ghost. We don't know if the core collapsed yesterday, a century ago, or if it will resist for millennia more. We merely receive the ancient photons from a nuclear furnace that may already be extinct. The star we see in the night sky is merely a luminous echo traveling through the dark vacuum. The true Betelgeuse of the present remains invisible, hidden by the finite speed of light. In our next episode, we will investigate Challenger, the 73 seconds that stopped the world in 1986, an engineering failure recorded in real time against the cold blue of the stratosphere. Until then, the hunter's reddish silhouette continues to shine silently high in the constellation, pouring ancient light upon a planet that still watches the sky, waiting for the shockwave.